This is an A-level pure question, a trigonometry pure question on solving trigonometric equations. Part I. Solve for x greater than or equal to 0 and x less than pi over 2 the equation 4 sine x is equal to sec x. Okay, so the first thing we're going to do is to write that sec x as 1 over cos x. Then we're going to times both sides by cos x to give us 4 sine x cos x is equal to 1. Now we can use a double angle identity to deal with this, and a double angle identity is that if we have sine 2x, that's equal to 2 sine x cos x. And you can see that we've got 4 sine x cos x, so we've got two lots of sine 2x. So the equation now becomes 2 sine 2x is equal to 1. Divide both sides by 2 and we'll have sine 2x is equal to a half. Now I'm going to do the sine inverse to both sides. So I'll have 2x is equal to the sine inverse of a half. Now remember, we are in radians because we've got the pi symbol here. And on our calculator, we'll get 1/6 pi or pi over 6. Now notice here that I've got 2x and the 2x is here. So what I'm going to do is to change my range from x to 2x. So my original range is that x is greater than or equal to 0 and less than pi over 2. If I now times everything by 2, I will get 2x is greater than or equal to 0 or less than pi. And this is the range that I'm going to use on my cast diagram between 0 and pi. So now we draw a cast diagram. So that's simply just a cross like this, where we have 0, pi over 2 because we're in radians, pi, and 3 pi over 2. And we're going to plot our principal solution that we've got for our calculator, and that is 2x is equal to pi over 6, which is 30 degrees. So that's going to be here on my cast diagram. So I'll label it as pi over 6. Since we are solving an equation for sine, what we do is we reflect this line in the y-axis. So if I reflect in the y-axis, this gives me the other solution that is between 0 and pi. Remember, I don't need to go any further. So if I sort of highlight it and show you, I'm only going from 0 around here to pi. I've doubled it. So what I've got so far is that 2x can be pi over 6. That's the principal solution. And then from my cast diagram, my other solution is going to be pi minus pi over 6. So write down pi minus pi over 6. So if we work that out, we've got pi over 6 and 5 pi over 6. Now that's what 2x is, so we need to divide by 2 to calculate x. So x will be pi over 12, and it will be 5 pi over 12. So that now represents our final solution to the original equation. Part 2. Solve for theta greater than or equal to 0 and less than 360 degrees. The equation 5 sine theta minus 5 cos theta is equal to 2, giving your answers to 1 decimal place. Now, because of the form we've got here, I can't factorize it. I can't make any substitution in terms of trigonometry to get something that I can factorize to find solutions. So this is a different method. And actually, this is going to be the r cos or r sine theta method. And it's going to be theta plus or minus alpha, or r sine theta plus or minus alpha. So I'm going to take what I have here and write it in this form, and that will give me an equation that I can solve. Now, depending on which form I decide to write it in, will decide the values of sine alpha and cos alpha. Now, it's best to pick the one that matches best with this and doesn't involve us having to change things around or fiddle around with negative signs. And I think the one that matches best with this is this form here. So I've got a sine theta first. So that means that I can write cos alpha equal to 5. So can you see the form matches up? So I've got sine theta times by cos alpha. So sine theta times by cos alpha. So cos alpha is 5. And then if I continue with the rest of the expansion, that's the expansion of r sine theta plus or minus alpha. We'll decide whether it's plus or minus in a moment. And then I've got cos theta, so I've got cos theta there, and then sine alpha, and sine alpha is going to be 5. Now the reason why sine alpha is going to be 5 and not minus 5 is because I'm going to be using the expansion of r sine theta minus alpha. So that means this is going to have a minus sign, which means the expansion has a minus sign, which matches with the minus sign here. So that means that sine alpha will be positive 5 because we've already got a negative from the expansion. So now we're going to work out r and alpha. Now r is always just the square root of the two numbers squared. We do Pythagoras on the two numbers, and the two numbers are 5 and 5. So the square root of 5 squared plus 5 squared, and that's the square root of 50, which is 5 root 2. And then we can work out alpha, and tan alpha is equal to sine alpha over cos alpha. Sine alpha is 5, cos alpha is also 5, so that means that alpha is going to be equal to the tan inverse of 5 over 5. In other words, the tan inverse of 1. That means we get alpha equal to 45 degrees. Now remember, we're switched from part A, which was in radians. This is degrees. Now what does this mean? This means that I can write 5 sine theta minus 5 cos theta equal to 2 can be written in this r sine theta minus alpha form. R is 5 root 2, and then sine of theta minus 45 degrees is equal to 2. So this is the equation we're going to solve. So our first step is going to be to divide both sides by 5 root 2. So that gives us sine theta minus 45 degrees is equal to root 2 over 5. We'll now do the sine inverse of both sides to get the value of theta minus 45. And remember, we're still in degrees. So our values for theta minus 45, or our principal value for theta minus 45, is 16.42994, and it continues. I want to find other solutions, if there are any, for theta minus 45. And like I did with the last question, I'm going to change the range so that it's theta minus 45 to work out whereabouts in my class diagram I need to look to find solutions. So I'm taking my range, which goes from 0 to 360. And basically what I'm going to do is to take away 45 from all three sides of that inequality, and I'll have minus 45 is less than or equal to theta, which is less than 315. So on my cast diagram, I'm going to be looking between negative 45 and 315 degrees. So we'll draw a cast diagram, put our degrees on, 0, 90, 180, 270. We'll put on our principal solution, that's this 16.429, so I'll just call it 16.4, just because I haven't got a great deal of space. Because we're solving for sine, we are going to reflect the line in the y-axis to find the other solution, so it's all symmetrical. So my other solution for theta minus 45 is going to be 180 minus this value here. And what that gives me is a value of 163.57005 and so on. So now I add 45 to each one of these solutions here to get the final answer. So the first one is, and I'll write the full thing down, I'll round it in a moment, 61.42994. And the second one is 208.57005 and so on. So final solutions, final values of theta given to one decimal place. So the first one 61.4 degrees and the second one 208.6 degrees. Correct to one decimal places because that's what they wanted in the question. So there we go. That's the second part of this question done.